Welcome to The Explainer. This is where we break down big ideas. Today, we're going to learn how to X-ray an argument, how to see right through it to figure out if it's actually solid or maybe just a clever trick. All right, let's start with this argument right here. It sounds pretty convincing, doesn't it? It connects something solid, like science, with a big philosophical idea. But you get that feeling, right? Something just feels a little off. To find the flaw hiding in plain sight, we've got to learn to think like a logician. So, what is actually wrong with it? I mean, we can't just go with our gut feelings, because honestly, persuasive language can fool pretty much anyone. We need a better tool for the job, something more powerful, like a way to X-ray the argument and see its actual bones. Okay, first things first, we all get tricked. It happens all the time. Arguments can be super deceptive, you know? They wrap themselves in really convincing language to hide the fact that their logical structure is, well, broken. They make us nod along to conclusions that feel right, but when you really look at them, they just don't hold up. And this is our X-ray machine. It's called formal logic. It's this amazing method that lets us just strip away all the flowery language, all the distracting topics, so we can look directly at the bare-bones skeleton of the argument. The whole point is to reveal the pure structure that's holding it all together, or not. So how does this decoding thing actually work? Let's dive in and see how we can take a messy, real-world argument and translate it into a crystal-clear language that we can actually analyze. Okay, now this is where it gets really cool. Just listen to these arguments. They sound completely different, right? The first one is about a car. The gas tank is full or the engine isn't running. The engine is running, so the gas tank must be full. The second is about a person. Tony is a woman or Tony is not pregnant. Tony is pregnant, therefore Tony is a woman. They're talking about totally different things, but, and this is the key, they share the exact same logical blueprint. P or not Q. Q. Therefore, P. That blueprint, that's the form we're hunting for. And that separation is everything. That logical form is the underlying structure. It doesn't care if we're talking about cars or people or planets. It's totally independent of the content. And learning to spot this form, that's the first, most critical step to X-raying any argument that comes your way. You know, a good way to think about it is like this. In physics, right? They talk about frictionless planes or weightless pendulums. These things don't exist in the real world, but they create a perfect, idealized model to understand the basics of motion. Well, logicians do the exact same thing. They use formal language to create a clean, perfect space to analyze the messy, complicated, and often ambiguous arguments we use every single day. This brings us to our first really big concept, validity. Now, an argument is valid if its structure is so solid that if, and that's a big if its premises are true, then the conclusion has to be true. It's a guarantee. But here's the crucial part. Validity has nothing to do with whether the statements are actually true in the real world. You could have a perfectly valid argument that's just full of complete nonsense. All validity cares about is the skeleton. Is it put together correctly? That's it. But okay, just having a valid structure isn't enough, right? I mean, for an argument to be something you can actually trust, it also needs to be sound. And a sound argument is the whole package. It's got a valid form, and all of its starting points, its premises, are actually factually true. This is the gold standard we're looking for. Let's break this down with the table here. Look at that first row, valid but not sound. You've got all dogs are mammals, which is true, then all mammals are cats, which is obviously false. But the structure leads to all dogs are cats. The form is perfectly valid, but because you started with a false premise, the argument isn't sound. The skeleton's good, but the building blocks are bad. Now look at the second one, invalid. All dogs are mammals, true. Some mammals live in water, also true. But the conclusion, some dogs live in water, just doesn't follow. Why? Because those mammals could be whales or dolphins. Here, the facts are true, but the logical skeleton itself is broken. And what's really powerful is that we can even visualize this stuff. Take a simple Venn diagram. If we have a statement like all S are P, let's say all senators are politicians. It just means that the entire circle for senators has to be completely inside the circle for politicians. There's no part of the senator's circle that's hanging out on its own. That shaded area you see, it's empty. It's basically a visual proof, which is pretty neat. All right, so now that we have these tools, let's go on the hunt. We're going to look for some of the most common traps in arguments, which are better known as logical fallacies. Okay, first up is one of the absolute sneakiest fallacies out there: equivocation. This is a real trap. It works by taking a key word in an argument and subtly changing its meaning halfway through. It makes it seem like the logic holds up, but really the goalposts have been moved. And with this new tool, we can finally solve our original puzzle. The X-ray shows us the hidden flaw plain as day. The argument was using the word law in two completely different ways. On one hand, you have a natural law like gravity. It just describes what happens. On the other hand, you have a moral law, which prescribes how we should act. See the difference? The whole argument only looked good because it was basically cheating with language. All right, here's another classic you'll see all over the place: the quantifier swap. This one is all about those little words that make a big difference, like all and some, or every and there exists. You gotta be careful because swapping their order can completely change the meaning of a sentence. This example shows you exactly why this is so important. Let's say it's true that every club member drives a sports car. Totally plausible. But can you then say there is one specific sports car that all the members drive? Of course not. That would mean they're all sharing a single car, like a huge carpool. The argument doesn't work because it illegally flips the order of every member and a car. The logic just completely falls apart. Okay, so we've peeked behind the curtain and seen how logicians do their thing. The real question is, how can you take this and build your own mental toolkit? How do you start thinking like this every day? So here it is, your mental toolkit. The next time you hear someone making an argument, try running it through this checklist. Step 1, pull the form apart from the content. Step 2, check if that underlying structure is valid. And step 3, keep your eyes peeled for those sneaky, shifty words. And always be skeptical when you see all and some getting swapped around. And seriously, don't think this is just some abstract mental exercise. This kind of structured thinking, it's the absolute bedrock of so many things we rely on. We're talking computer science, artificial intelligence, modern philosophy. It is literally the engine running in the background of our entire digital world. And that leaves us with a pretty big question to think about, especially for our time. In a world that's being shaped more and more by algorithms, does that make our uniquely human skill of applying logic even more critical than ever? That's something to chew on. Thanks for joining us on The Explainer.